Hello, my name is Nathan Diazleal, and today I'm going to be going over NOx sensors or nitrous oxide sensors, and these sensors are specifically used for diesel applications and aftertreatment. So before we dive into NOx sensors, let's review diesel combustion. Diesel is a hydrocarbon that reacts with oxygen inside the air, and as you can see here in this figure, diesel is a very large and long molecule, which its average chemical formula is C12H23. And on the other side, gasoline is CH8H10, which is a lot smaller. But because diesel is bigger, it releases more energy when it combusts. And diesel combustion also uses compression ignition instead of spark. So once the piston reaches top dead center on the compression stroke, diesel is injected into the hot combustion chamber, which the hot air will ignite the fuel, as you can see in this GIF here. And since we're dealing with high compression ratios and a very large hydrocarbon molecule, diesel combustion becomes a little difficult to control efficiency-wise, and we get emissions. Diesel's long molecular geometry makes the molecules more likely to stick together, so diesel likes to stay in liquid form rather than evaporate. Sometimes liquid diesel will touch the cylinder walls and not fully evaporate. This figure down here shows what happens when diesel is injected into the cylinder. This creates a different flame front compared to an even gasoline flame front. As you can see, there are different areas that vary in temperature. This variation can lead to the formation of particulate matter, soot, carbon monoxide, and other various emissions. And also, the high temperatures from combustion can also accelerate the formation of nitrous oxides and also other various solids and aldehydes. As you can see from this pie chart up here, there is a lot of different emissions that come from diesel combustion. Luckily, manufacturers have found a way to filter out emissions through a series of catalysts called the aftertreatment system, which is shown here. This system consists of a diesel oxidation catalyst, or DOC, which is used to oxidize HCNO, CO into CO2, water, NO2. And then followed by that, we have the DPF, or the diesel particulate filter, which is used to store some solids, soot, and particulate matter. And then after that, we have the SCR, the selective catalytic reduction catalyst, which this is used to reduce NOx. So for this presentation, we're going to be mainly focusing on the SCR. So the SCR works with diesel exhaust fluid, or DEF, and DEF contains urea. So this DEF is injected into the exhaust stream where the urea will break down into ammonia and carbon dioxide, as you can see here. So the SCR will use this ammonia to help break down NOx. So this DEF is injected with a DEF injector, and this DEF injector will determine how well and how efficient NOx reduction occurs in the SCR. Finally, getting into NOx sensors. NOx sensors are used as a feedback device for DEF injection operation, verifying DEF injection, and the overall SCR operation. So NOx sensors work very similar to AF sensors and O2 sensors. So like O2 sensors, there's an inlet sensor after the turbo and one after the SCR. But on some light-duty diesels, there actually may be a third sensor, which is used after the NOx storage or the NOx trap catalyst to determine how much NOx was stored in the catalyst. NOx sensors are pretty complex, so they need to have their own module, which NOx sensors are sold and manufactured with the modules as complete units. This module does all the necessary calculation, controls the heater, controls the overall NOx sensor operation, and self-diagnoses problems within the sensor itself. So this module will communicate via CAN or using a different network to the ECM or after-treatment module. So because there's a module, this may make diagnosing them and repairing them a little bit more difficult or easier. It kind of just depends on the situation. So going into the NOx sensor operation, so NOx sensors work very similar to a AF, critical current, or ion pumping type oxygen sensor. So we're going to have three chambers, an O2 pump cell, a NOx sensing cell, and a reference chamber or air chamber. So to begin, we're going to have the exhaust gases enter the O2 pump cell. And inside this pump cell, we're going to want to burn off some extra hydrocarbons and some carbon monoxide into carbon dioxide and water because that can actually mess up with our readings. So there may be some sort of small oxidation catalyst. So what's also going to happen in this O2 pump cell is there could be an initial O2 reading, which can be used, to determine the AF ratio, but that isn't really necessary for some heavy duty diesel applications. So more than not, this pump cell is really just going to be used to pump out that extra oxygen and just burn those other gases that aren't necessary because these are going to really mess up our NOx sensor readings. So after that, it's going to enter a diffusion chamber in here, and there's going to be a NOx reduction catalyst, which this is going to, do the same thing as as the SCR. It's going to break down the NOx into N2 and O2, where this O2 is going to be ionized and do the same exact thing as an oxygen sensor and read the difference in potentials between the NOx sensing cell and an air reference chamber, which that will actually be our NOx reading. So there may actually be there's actually different types of NOx sensors which may not use a reduction catalyst. They may actually use kind of like a reduction catalytic electrode type thing, which they will take like NO and actually just reduce it on the electrode itself to just use the oxygen that's there. But it still does the same thing as, as any NOx sensor. It's trying to read that NOx concentration. So the easiest way to think of a NOx sensor is pretty much just an AF sensor that's able to break down NOx. So this wiring diagram on the right is typically what a technician will see when they look up a NOx sensor. There could be 2 to 4 networking wires going to the NOx sensor module. It really just depends on the information bus configuration. So there will also be a power and ground going to the NOx sensor module. So diagnostic wise, the technician may only check if there's proper power, ground, and if it's receiving any signals from other modules. And then the figure on the left shows the wiring going to the sensor itself. So it's going to be an O2 cell control, NOx cell control, and then the heater control from the module to the sensor. But like an AF sensor, it's really not recommended to start back probing on the sensor side because it could damage the module, the wiring, or the NOx sensor itself. Most of this diagnostics will be performed with the scan tool, and there isn't really much reason to back probe since the sensor itself is just going to be replaced with the module. So depending on how a NOx sensor fails and what manufacturer it is, there will be various symptoms. There will usually be a very specific DTC associated with the failing NOx sensor. The DTC will usually tell you if the sensor has a faulty internal O2 or NOx sensor, cell control, heater control, or a faulty networking wire or something like that. But if there isn't, typically a bad NOx sensor can cause an inoperative or an erratic depth injection pulses and poor SCR operation overall. But actually, depending on the manufacturer or even like a fleet manager, the vehicle may be derated or disabled. The ECM can be programmed to put the vehicle in an idle mode only or a low speed mode if the NOx sensors or the DEF system becomes erratic or fails. So the things that can cause a failing NOx sensor range from fatigue to improper installation to contamination and water damage. So these NOx sensors are very sensitive and delicate. So sometimes a failing engine can cause premature NOx sensor failure. So it is a good idea to verify if the engine is working good, if the SCR and DEF system are working properly before determining if a NOx sensor is faulty. Also, leaky exhaust can cause false NOx sensor readings, so it is a good idea to visually inspect and understand the symptom before diving too deep into diagnosis. You never know, the NOx sensor may just need to be cleaned through a regeneration. So right here on the right, I have a symptom to system chart that kind of gives a general idea of some of the type of failures that you might encounter and what kind of has caused them. So because NOx sensors are sensitive and have their own modules, a faulty NOx sensor can have various DTCs show up. These will range from performance issues to heater control issues to O2 or NOx sensor operations. So the manufacturer DTC-based diagnostics procedure and generic NOx sensor diagnostics procedure, which may be, a symptom-based diagnostics procedure, is going to be just about the same steps since we can't necessarily bench test or back probe a NOx sensor. So let's go over an example of a 2018 Chevy Silverado 2500 Duramax diesel NOx sensor DTC-based diagnostics. So before beginning this manufacturer diagnostic procedure, you're going to want to make sure that the engine, the SCR, and the DEF system is performing as it should, and also make sure that the NOx sensor modules are receiving proper power and ground and signals from other various modules. So this procedure is really only going to need a scan tool and a test drive. So to begin, make sure that the vehicle and the NOx sensor heaters have reached normal operating temperature. This warm-up could take longer than 5 minutes. So after the warm-up, you're going to want to disconnect the def injector and then make sure that the NOx sensor heaters are displaying on inside the scan tool. So after that, you're going to let the engine idle and park for about 10 minutes. And then after that, you're going to make sure that NOx sensor 1 and 2 concentrations are greater than 80 parts per million and within 50 parts per million of each other. NOx sensor 2 must not be greater than 30 parts per million of NOx sensor 1. If any of these conditions fail, then move on to the next steps. But if these pass, then more than likely the NOx sensors are working okay. So here I have an example of good scan tool data. These numbers that you see here are pretty much just values that you're gonna see when the engine is off and the key is on. That means that your NOx sensor isn't on and it's not active yet, or something's wrong with the NOx sensor if you're seeing that when the engine's running. So you can see that we see it for our NOx sensor 3. So right now the NOx sensor 3 is actually not warmed up yet. So that's pretty much what we're seeing here. So in this next couple seconds, you're going to see that the NOx sensor 3 is going to become active. So now we have an active NOx sensor 3. So at idle, these are all at idle, so these are all relatively consistent. They're all pretty close to each other, nothing really out of the ordinary. And as you can see, we actually also get to see the oxygen concentration versus a NOx sensor concentration too. So we're going to have different types of NOx sensor readings. There could be, like I've mentioned right now, the oxygen concentration. There could be a NOx sensor concentration and NOx sensor like correction factor or something like that. So sometimes the NOx like reading may actually be a little bit inaccurate. So the module itself corrects for it. So there's going to tell you like a before and after. So you're not going to want to see too many like if you see too many erratic values, that's going to signal something. So now what I'm showing you here is acceleration. So you can see like an oxygen sensor is starting to respond to the throttle input. We're getting a lot more, a lot more NOx is getting built up as the RPMs are rising. There's a lot more load and everything. So this is showing pretty good values. This was taken before, so the NOx 3 isn't active yet, so that's why that number is still negative. But overall, like during acceleration, you're gonna see like you should see an increase in the NOx. If you're not seeing an increase, something's wrong. So during the decel, you're gonna want to make sure that these values are still staying consistent. You don't want sensors to hang and things like that. So if the NOx sensor concentrations were off, you're gonna want to reconnect that def injector and then begin the test drive. So after that, you're going to perform some heavy wide open throttle events and accelerations for about 3 to 5 seconds and immediately left the throttle and decelerate. So you're going to want to make sure that you're recording the scan tool data, and you're going to want to repeat this as many times as you can. So things to know would be that if the NOx sensor 1 concentration is greater than 20 parts per million during the decel, this would indicate a failing NOx sensor 1. And during decel, if NOx sensor 2 concentration is greater than 50% of its peak value during the acceleration event, then that would indicate a failing NOx sensor 2. So right here is pretty much just a normal scan tool waveform. So what we're going to see is some waveforms at idle and at some wide open throttle events. So some things to know is you want to make sure that you're using a longer time base so you can zoom out and see what the waveforms look like in 20, 30 seconds. You don't want to zoom in too close because you're not going to be able to see some big changes. And also you're going to want to make sure that if you can kind of stack up the sensor waveforms together and see if you can see them all together, because it's going to be a little easier to understand and really break down once you start to go deep into it. So something you could actually see with these waveforms is the def injector. So if you can activate the def injector with the scan tool or a different method, then you could see that the NOx concentration should begin to go down because you're injecting more urea, more def. So the SCR is starting to, reduce the NOx. So you should definitely see a decrease in NOx concentration. So as you can see, we have a lot of, constant values, which is pretty good because right now these values were taken at idle. So now we're going to be at acceleration. So we're going to definitely see maybe possibly a decrease in oxygen concentration because we're going to have a quick rich mixture. And then we're going to should see an increase potentially an increase in NOx because what we want is, we're starting to increase the combustion. We're doing a lot more combustion events, so things are getting hotter. We're starting to create more NOx. So this video is a little bit slowed down, so things may look a little choppy, but it's just so it becomes a little bit easier to kind of see all the waveforms together. So you can see that things are still pretty consistent because we're just in park. We're not really under too much load. But if you were under more load, you can see that like the NOx concentrations are changing. But still, you see that things are still changing. They're responding the way they should. So if you're not starting to see like erratic waveforms, then that definitely shows that something's wrong with the NOx sensor. So here in this picture, what we see is if you're able to stack the NOx sensors waveforms together, then you can see that when you start to activate, the throttle and you start to accelerate and decelerate, that the NOx sensors should be really close to each other, about 50 parts per million within each other. And as you can see that these values should like rise and drop with the RPMs. If either sensor hangs, then you could probably suspect that something's wrong with the sensor. So here are more examples of what you would see if one of the NOx sensors is failing. So here you can see that the NOx sensor, the inlet and the outlet are pretty far from each other, and then also they're starting to drift away. So that means that something's going on with those sensors. And here's like a really big example of, an oscillating sensor that really should not just be oscillating like that. It should just be relatively consistent like the inlet up here. So these are just more examples of what you would see. In summary, diesel combustion creates the toxic gas NOx, and we have NOx sensors that can read the O2 from the NOx to determine the NOx concentration. This will be used for the DEF injector feedback and to determine how well the SCR is operating. NOx sensors also have a diagnosing module which controls the overall NOx sensor operation. Most of the diagnostics will be performed using a scan tool and a test drive with the vehicle. NOx sensors may seem intimidating at first, but it's really just an AF sensor that is able to break down NOx.